So can you hear me now? So if you can hear me, type something in the chat box so I can see it. But the chat box has some lag. Let me just start this. But I need to know, right, for each of the question, whether this question is for junior group or maybe the open group or both. So if you know, just tell me here, okay? So I know that first question because both a junior and an open student tells me about this. So just, this question must belong to both junior and open. Okay. So now this one should be an easy question, but since it includes some negative number, it might confuse you. So what if without negative number? So if all of these are positive, which means we can write it down like this. This should be something that you're familiar with because we can write a thing like 2/3, 4/3, it's the 3/4, 5/4. And then in the end is the 2024, 2025, 2026, 2025. So all the midterms can be cancelled out except for the first one and last one. So which means it should be and 4/5/6. So overall 1,000 even numbers. So total negative term. So I have all views of maybe I was. 你们在看都看不好的，你们能看到？那个把这个图发我，有人发到你们这个图发我了。OK， 我可以等。那我来弄这个 video。对，头呢 ？OK now， now， 忘也套了吧？签。哎呀，这些东西出来的很多。不是，是我这边卡着雅倩那边卡，我的意思是。是你这边卡。不是我们看的卡，不一定是我这卡，可能是他那边卡。他看我卡，要看雅倩看我卡。我刚一开始不是雅倩那边。不是，就是我要知道推流那边卡还是这边卡，这个是不一样的呀。反正你放我那边去吧，我这边好一点。你看这个好像是好的，现在好像是好的，现在好像是好的，现在好像是好的，现在好像是好的，就是反正没有人。啊，现在可以了。我这边没问题，应该是你那边的网的问题，我感觉。OK。现在好。啊，现在好了。那 T 老师，你在群里面发一下呗。你在群就是刚才网络有问题，现在重新开始了。So some network trouble. I think they handle it now. Okay. Yeah, then we start. Let me start. Okay, I don't know if they handle it or not. So we finished the first question, right? Okay, then we go to the second one. So I suppose the second one is also for junior and open both, since I received 2 copies of it. And then, so we know the area of the 3 square, which means the side length is the 1, 2, 3, right? And then the easiest way to solve this question is use the similar triangle and a similar model to solve it. This is the easiest method. So now we can just, right, this is 1. Now this is 1, 3, 2. 1, 2, 3. And this is 1. This is the 2. So which means if you look at this right angle triangle, the lag ratio is a 1 to 2 here, right? The lag ratio is 1 to 2. So which means, so all of this triangle like this is also a 1 to 2. And then moreover, if you draw the perpendicular lines here, this triangle is also a 1 to 2. So now this side is 1, so this is 0.5. And then, so for the top, we don't know about it, but never mind. So we can assume this is the A, this is the 2A. And for right side, the same thing. So this is the 2, 2, 1, 2, right? So this blue triangle have the lag ratio being 1 to 2. So this blue triangle is also a 1 to 2. So this is the 2, this should be a 4 here. And so now, for this blue triangle also is the 2A, and then this is the 4A. And because this A and 4A make together, this 5A is the side length 3, which means 1A should equal to 0.6. So now this is the 0.6, and then this is 2.4. And this 2A here would then be 1.2. So now we want to find the area of ABC. We should know the base and know the height. So the base, 0.5, 1, 3, 2, and a 4. So it's the 10.5. Height, on the other hand, so this is the 3, this is 1.2, so it's the 4.2. So the area is half times 10.5 times 4.2. So it's half, it's 441, 2205. So it's 22.05. This is the final answer. If you want to write it down, you can write it down like the 441 over 20 is the same thing. Right. So this is about the second question. This is about both junior and open. So the third question, I suppose is in junior only, right? This is only junior question. Yeah, this is only the junior question. And then, so we have 1 to 7 in a circle. So every two adjacent number product does not exceed 20. So now how many ways are there? So for this question, we should focus on the large numbers, right? So we have the 7 positions, 1, 2, 3, 4, 5, 6, 7, right? So because the large number is always harder for us to arrange, so we try to start with a large number. So first we put the 7. We find the position first to put the 7, which we have 7 ways. And then, so after we put the 7 here, 7 can only be adjacent to 1 and 2, right? 7 can only be adjacent to 1 and 2. So which means the left and right side of the 7 must be 1 is to 1, 1 is to 2. So it can't be either side. So 1 and 2 have 2 ways. And then suppose this is the 1, this is the 2. And then since we already handled with the 7, then we go to the 6. 6 is the second largest number, right? So 6 can be adjacent with 1 or 2 or 3. So now 1 and 2 are separated, so 6 must be adjacent to one of them, and another side is the 3. So now 6 must be either after 1 or after 2. So 6 would also have 2 ways to put on right or left. So maybe suppose the 6 is on the right, and then adjacent to 6, there must be a 3, right? And then for the remaining 4 grid, the remaining 2 grid is the 4 and 5. Well, 4 and 5, they're putting together here. The order is not that important. Anyone can be adjacent to 1, 2, or 3. So now 4 and 5, they can have 2 ways. So the final answer would then be 7 for position of 7 times 2 times 2 times 2. So which is a 56 ways. Yeah, 56 ways. So this is for the junior question. This is a junior question. Yeah. Question 4, right? This description is wrong. Hey, Turner, I don't ask you to input this version. Never mind. So this question should go like the way like this. I need a updated version of this question. So now this question should go this way. So there are n team for a round robin game. So now winner got 3, draw get 2, loser get 1, right? And then, so the sum of 3 of them, any random 3 teams, we don't know which 3 teams, is 26. And then we want to find the largest possible value for the highest. Yeah, so this question should go this way. So this question is both in junior and in the open. So Turner, please change this question in this description. So this question is hard, actually. So understanding this question is already very hard because we don't know the values in. But then if you want to make the max score, right, to be as high as possible, we should make this n as large as possible. So which means we should make this 26, right? So this 26 must belong to maybe the 3 of the lowest points. And then we just need to judge from the 3 lowest points. So they should lose as many as possible so we can get as many people as possible. So now we look at the 3 teams. So we put this point in 2 ways. The first way, right, this is very important thing. We call this first game is the inside game, or maybe inner game. So inner game means that, so game played within the 3 teams. So obviously, so they totally together, they play 3C2, they play 3 games. And in each of the game, so they should gain, right, in total, because win 3, lose 1, draw 2. So the total score gained by each match is always 4 points. So which means among these 26 points, there are always 12 points comes from the inner game by the 3 players. So now, the outer game, the total points is made by 14, right? So now there's 14 points. So 14 points. So how many games are there? So each team should play against another n-3 teams, right? So now for 3 times of n-3 teams, games, right? Yeah. So now, after that, interesting is, totally they win 14 points, and then in 3 times n-3 games. So now we can get 3 times of n-3 should be smaller or equal to 14. And then because it's multiple 3, so n-3 is at most 4. So n is at most 7. So which means there are at most 7 teams here. So this is the logic to solve this question. There are at least 7 teams, and most 7 teams in this game. And then what is the maximum score for the first one? The first one can win all these 6 games. So which means the highest possible is for the first one to win all the 6 games. So it's the 18 points. So the answer for this question should be 18. Okay. But the question is hard. This question is hard. So it's hard to understand this question. So many students just don't understand what the question talks about, and then give up for this question. And also the question 5 is wrong. The question 5, the description is wrong. So I should change it into the correct version. So now this question says that it's the largest 2-digit number cannot expressed as AB plus A plus B, right? So this is very common thing because AB plus A plus B equal to A, and maybe not A, maybe the N. So now this is the basic factorization to make it A plus 1, B plus 1 equal to N plus 1. So if N plus 1 cannot be expressed into the product of 2 numbers, so this number must be a prime number, right? If this one is a prime number, then N is at most 96. 6, right? N is more than 96. This is also both in junior and open. Yeah, this is both. This is also for junior and open. Okay. Question 6. Is this question 6 in open? It must be in the junior. I don't know if this question is in the open or not. Anyone knows? Anyone tells me? Is this question in open or not? So this is 90 degree. This is 150 degree. And then BC equal to CD equal to AD. And we want to find the angle A. We want to find the angle A. This picture is not accurate. This picture is not accurate. So I have to say in the real test, how to solve this question, draw the picture and measure it. Okay. So now this is for short answer. So measuring is always the best method for it. Draw a standard picture, measure it, problem solved. And so now go back to this question. So how do we really prove it? How do we really, so if we measure out the answer, how do we get it, right? So now the logic goes this way. So if you use the measurement, you can easily figure out this angle is a 45 degree, but then just how to prove it. We draw the picture this way. So this is A. So this is 90 degree, 45 degree, right? And then we have a 150 degree out here. So this is a 105 degree. So this is also the A. And then based on the Pythagorean theorem, this is root 2A. So see this A and root 2A, what do we recall? So maybe we can just use another way to draw a root 2A, just go this way. If we draw a 45 degree, okay, we draw a isosceles right, maybe not like this, maybe in another direction. So this is perpendicular. Maybe something like this, right? Okay. So now I draw a new triangle, right? I draw a new triangle like the A. This is the A. So now we get a root. So we get a new root 2A. And so this angle, on the other hand, so it's a 60 degree. So which means this is C, this is the A, this is the D, this is the B, right? We call this point AE. So now we can get the triangle BDE equal to a equilateral triangle, right? So now we look at what is this AB. So now this line AB actually is the connection of B and A, which they are all the vertex of two associated triangles. So which means AB perpendicular to DE. Also, we can get the angle 1 equal to angle 2 equal to 45 degree. The trinity line of a associated triangle. Okay, then problem can be solved. So why my screen share is weird? So I mean, the screen share is weird. It shouldn't go like this. Maybe I change, let's stop it, restart it. Maybe it's better. Just notice that the screen share is weird. Okay, this is better. This is better. Okay, so now is this question in junior or open or both? Or both? Never mind, I will check it afterwards maybe. Right. So then for the question 7 is just easy. Question 7 is just easy. So the RMMO adding together is the RMO. So obviously R is the 1, right? So first we can know that R is the 1. And then secondly, because R plus M plus O, right? The last digit, R plus M plus O is still the O. So which means this M here must be a 9, right? This is only to make that happen. If you have a carry over 1 here, right? And then we should see that, so R plus M plus O equal to 10 plus M. So then we have the 1 plus 1 plus O equal to M, equal to 10, right? So O should equal to 8, right? This is the only solution, 198. Yeah, 198. Very easy question. So this question is in junior, but I don't remember if it's open or not. So anyone tells me this question is open or Seems that it's junior only because it's too easy. This one is just too easy. I suppose it's only in junior. So the question 8 is in junior and open both. I'm so sure about it, right? So the question is both in junior and open. So now we know that the 2x over x plus y is between 11 over 2025 and 13 over 2025. And y over x is the integer. So it's not, the question is not about asking how many group x and y do we have. It's about asking how many possible values for y over x are there. Yeah, this question should ask the way like this. And then, so how many ways are there? How many ways are there? So now we just try to solve this expression by making it into the y over x. So first, we take the reciprocal of this. If we take the reciprocal, we can get the 2025 over 11 larger than x plus y 2x larger than 2025 over 13. Right? Okay. And then, so for this one, we may just times a 2 on each side. We times a 2 on each side, so which means is a 4050 larger than, this is x plus y over x larger than 4050 13. And after we make this one into 1 plus y over x. And then we just need to make this one into a, because y over x is a whole number, we just make the range of this. So now this one, if we make it, if we calculate it, is some 3, calculator. 4050 minus over 11, 368 and something. And something. We don't care about the something, right? And then this is the 311 and something. So now this y over x, right? Because we need to satisfy this range. So now y over x is a whole number, so it's at least 311 and most 36, can we reach 7? Yeah, 367, right? So how many values, possible values are there? 367 minus 311 plus a 1 is a 57, right? So the answer is 57. So the question 8 is both in junior and open. Then question 9. Question 9 is hard, actually. Question 9 is hard. So it's an old question, but it's hard. It's not like the normal place value principle problems. Now I said that the last digit of a number is 6. So some number 6. And then times a 4 becomes 6 and this backward number, right? The problem for this question is just we don't know how long is this number. How many digits are there? So maybe we just suppose this one have the x digit. So this one have x digit. And then we use the place value principle to extend it. So this is in junior. I don't know if it's in open or not. So I don't know if this question is in open on. I check. I check about the some question the open student sent me. And try to find if the question is inside of it. I don't know. I'm not so sure. So yeah, it's in open as well. It's in open as well. So it's in both junior and open. Yeah, it's both junior and open. Very good. So now the logic is, since we don't know the number of x, maybe still the x digit, we place value to extend it. So now this side should be 14 times this. So we call this whole thing as a y, maybe. We call this whole thing as a y. So it's 40y plus 24 to left side. On the right side is 10 times x to the power of x plus the y. Move all the y to the left side, we can get 39y equal to 6 times 10 to the power of x minus 6 times 4. And so now, this y can be any number, but we must be sure that y must be a whole number. So now if y be a whole number, which means this left side must be, the right side must be a multiple of your 39. Which means y. So no, it's the 39 can divide the right side. So obviously the right side is automatically a multiple of 3 because this is 6 times 10 to the power of x minus 4, right? This is why naturally a multiple of 3. So to make this y a whole number, we should make this 10 to the power of x minus 4 a multiple of 13. So 13 can divide 10 to the power of x minus 4. We just want to find the smallest possible x to make this thing happen. So now 10 to the power of x should have a remainder 4 when divided by 13. Maybe try it on the smallest x, try from 1, 2, 3, 4, 5, and then you should find that when x equal to 5, this is the first number to make it work. So the minimum value for this x is the 5. And then, so if x, the minimum value of x is 5, so in this case, the y should then equal to, you can do the calculation. You can do the calculation. It's the 10 to the power of 1 and 5 zeros, 1, 0, 0, 0, 0, 0, minus a 4. Okay, times a 6, then divides a 39. It's the 15384. Yeah. So the smallest possible number end up with a 6. So it should be 153846. Right. 153846. So this is for this question. Question 9. And then for question 10. If a number is a rival's prime number, so it means that this number right backward is also a prime number. You want to find the largest two-digit number that satisfy both n, 4n, and 5n are all rival's prime numbers. So maybe this one is the AB, right? So first of all, BA is prime. Then we can get A must be an odd number. A can either be 9 or 7 or something. Let's try if A can be 9. So now, if A equal to 9, so let's see, can we ensure that 4n and 5n to be a prime number? So A equal to 9. So look at 5n here. So 5n. So in this case, the smallest value for AB is the 90. So now 5 times 90 and 5 times 99. This is the range of this 5n, which means that, so this is the 450, this is the 495. So all this start with the digit 4, so which means this 5n is a 400 something something. The 100th digit of this number is a 4. If the 100th digit of this number is a 4, then when reversed, 4 should be the last digit of this 5n. It cannot be a prime number. So this is a contradiction. So which means all numbers start with 9 never work. Then we directly move to A equal to 7, right? When we go to the A equal to 7, we can find out that, so the largest number is 79. Let's just try 79. Does 79 work? 79 itself work. 79 times 4, which is the 316, and then we make it into a 613. Is 613 a prime number? Is 613 a prime number? So we need to check, right? So it's not a multiple of 2 or 3 or 5, obviously it's not 11. So check 7 first. So 61 minus 6, 55. So this is not a multiple of 7. And then try 13, obviously multiple of 13. No multiple of 17. So I'm so sure this is a prime number. 17, yeah, 19, then 23. Okay, this is a prime number, very good. So this is a prime number. Then 79 times 5, so it is a 395. So reverse it, it's a 593. Is 593 a prime number? 593, such a boring question, 593. So it's not a multiple of course, it's not a multiple of 2, not a multiple of 3, not a multiple of, well, so not a multiple of 5, and not a multiple of 7, not a multiple of 11. Try 13, no. Try 17, no. 19, 23, prime number. Prime number. Okay, so now, yeah, all these numbers are prime numbers, so the largest possible value is the 79. So this question is in junior, but it's in open. I'm not so sure. Maybe just mark the junior here. Mark the junior here. Okay. Question 11 is a junior question, and this is a very old question. They didn't even change the number, right? There are no MCQ options here because originally this is an MCQ question, but now they don't have the MCQ. So never mind, right? So this is the question 11. So the easiest way to find this is that, so the total pencil distributed to x, y, and z. So maybe we just need to find what is the LCM of the 42, 105, 98. So now we just find the LCM of this. So this is the 2 times 3 times 7, 357, 27 squared. So the LCM of this one should be 2 times 5, 2 times 3 times 5 times 7 squared, right? So this is the total. So the total number we just suppose is the LCM of all these numbers, right? This number unit. So which means the number of x, so no, the number of students in x, y, z would then be, so this one over 40, this one over 42, we cancel out 2, cancel 3, cancel 7, so it's the 35 unit. And then x, only the x, would then equal to this number divided by 105. We cancel out 357, so it's the 14 unit. For y, this number divided by 90 is 15 unit. So now the z would then equal to 35 minus 14 minus 15 is only 6 unit. So the number of z is 6 unit. If I want to distribute all the candidates to z, so now it should be, I don't really need to calculate this number out, just to keep it here. So it's the 5 times 49. So it's the 245. Yeah, so the answer 245. Okay. Question 12. Question 12, this is open only. This is the open question 8. This is open question 8. So for 12, 13, 14, 15, you need to write workings, right? You need to write workings here. So now, so for the question 12, this question is a pure secondary school question. It's a pure question, secondary school question. And this includes a very important, we call the, oh, Turner, you write this one wrong. Turner, you write this one wrong again. So what should this one be? Is it correct? Oh, it's correct, it's correct, it's correct. So now we want to make this a cube, b cube, 3ab equal to 1. So now we get a very important format. Do you know about this? So a cube, b cube, c cube, minus 3abc. This is a very formula expression here. So this one should equal to half times a plus b plus c times a minus b squared plus b minus c squared plus c minus a squared. Yeah, this is a very classic question. So this is a very classic question, actually. Is it going like this way? A squared, b squared, c squared. Yeah, it goes this way. It goes this way. It goes this way. Right. How does it help us? How does this one help us? So now look at the original format. We have a squared, b squared. So now this is 3ab. It's 3 times a times b times the negative 1. So which means for this one, we can just write it down this way. A cube, b cube. We write it down like plus or minus a negative, plus negative 1 cube, because we move this 1 to left side, and then minus 3 times of negative 1 times a times b equal to 0, right? And then, so we can, so now negative 1 stands for the c here, so now it's the a plus b minus 1. And inside this bracket, we have the a minus b squared plus a plus 1 squared plus b plus 1 squared, right, equal to 0, right? And it just goes this way. So now, it's either the left side or maybe half, right? So it's either the left side or the right side of this factor. It's a 0, right? The first case is just the a plus b minus 1 equal to 0. So in this case, we have the a plus b equal to 1. So how many combinations are there for a plus b equal to 1? And so since a and b, they're between negative 7 and 26. So now we just look at the value of this a, right? So now the smallest value for a can be as small as negative 7. The largest number for this a can be the 8, right? Considering the range. So which means we have 16 ways here. Right? We have 16 ways here. And then secondly, if this one is not a 0, then this one should be 0. So a minus b squared plus a plus 1 squared plus b plus 1 squared should equal to 0. And if the square number is always larger or equal to 0, the sum of the three is the 0, so which means all of these numbers, they're 0. So which means a minus b equal to 0. So a equal to b. And then a equal to -1, b equal to -1. So in this case, it's the a equal to b equal to -1. There is only one ways here. So in total, it's 16 plus 1. So we have the 17 ways, right? This question is hard. A pure secondary school question. A pure secondary school question, right? So then we go to the question 13. Yeah, 13 is open. 13, 14, 15, they're all open questions. They're all open questions. This question says that, so we fill 1 to 9 in this table. And then, so now in each operation, we can choose one row or maybe one column. And the operation goes this way. So in each time, we plus 1, maybe plus 1, because this plus k can be simplified into several times of plus 1. We plus 1 to a number on top. And then we minus 2 on the middle and the other end. So which means, so for example, in this row, we can make it into a 5, 4, 5. Or maybe we can make it into a 3, then this is the 6, and then this, no, it's always 4, it's always 4. 3, 4, 7, right? So this is the possible operations here. And the final question is, so is it possible to make all the numbers equal? We don't care if equal to what, equal to 0, 0, 1, or 2, or 3, both is possible, right? Is it possible to make all the numbers equal in this table? So notice that when we do this operation, right, there can never be a negative number here. So the final is at least 0. So this is a breakthrough point. So how to handle this question? You should notice that. So in a row or column, when we do the operation, so the middle number, when we do the operation, is always suffer the subtraction. Right? So for the middle number, right, it's always the subtraction. Which means the middle 5, no matter how you operate it. So the middle 5 cannot increase. All the other numbers can find a way to increase it, but the middle 5 can never increase. So which means the total operation in the central cannot overtake this 5. So that's the first thing we need to know. That's the first thing we need to know, right? And secondly, when we see this, right, operation in a rectangle grid, the chessboard coloring is always a method we want to use. It might not be the easiest way to prove it, but I prefer this method. So which means, so we can just color in this grid like this, right? Okay. And then, so after that, let's do the same. So we have 5 black and 4 white. So before, right, to start with, the sum of black is 25. The sum of white is 20, right? The sum of is 20. And so now, if we operate with the first two and the first and the last row or first and last column, we call this operation A, right? So when we do the operation A, each time we will result the sum of black region remains the same, but sum of the white region minus 1. The sum of the white, each operation A will make the sum of white minus 1. And the operation B, so one operation B then makes we make the operation B here. So all the white region, the sum remains unchanged. The top and the bottom, right? Plus 1, minus 1. But the middle one, the middle 5 must be reduced by 1. So the sum of black minus a 1, right? And then we have an interesting thing. So if we want to make the sum, right? We know the sum of black and white. We want to make all the numbers equal. Their average must be equal. So the average of black. So to start with is the 5. And then after we solve for each B operation, the sum of black decreased by 1. So now should be 5 minus the, so we must make the 5 minus B, the number of operation B over 5, right? So this is the average. And the average for the white, right? So the average for the white initially is the 5. And after we solve for each operation A, the sum of white decreased by 1. So the average decreased by 4 over 8, right? So now if we want to make all numbers equal, so now if all numbers are equal, so all the numbers should equal to the average of both black and both white. So the average black and white should all be equal, so which means B over 5 equal to A over 4, right? So B over 5 must equal to A over 4. And so which means A to B is a 4 to 5. So now, if we want to make all the numbers the same, based on the average, so we must ensure that the operation B to operation A's operating time is a 5 to 4. Okay? But we also know that the operation B is not cause any black region minus 1, but to be more accurate, is the grade 5 to minus a 1, right? So the operation B is always operating the central black region. So which means this one, how many times will it be suffered? So can only suffer 5 operations. So which means the operation time for B is at most 5 times. So the only way to make it possible, so if it's possible, then B must do 5 times. And then A, we must do operation A for 4 times. And if we do operation B for 5 times, so the central number must be equal to 0. So the central number would eventually go for 0, but the average number is the 4. So now, after 5 operations, the central number becomes 0, while the average is the 4. So will they able to be equal to each other? No, right? Because the central is not equal to the average. So all the numbers can never be the same. Okay, so this is for the question, yeah. This is the open question 9, right? This is the open question 9. So the answer is no. So I suppose this no already worth 1 point. The proof is hard. The proof is hard. But please tell me you do write the no on the answer, because right, write this no will worth 1 point, or maybe at least half the point. Okay, okay. That's the question 14. The question 14. So now a isosceles triangle, the height from A to BC is half of the length of BC. Find the value of BAC. So this question is easy. There are only 2 possible cases. The first, so because ABC is an isosceles triangle, we just need to see that whether BC is the base or BC is the leg. The first case is BC is the base. Then in this case, just go this way. So the height equal to half of BC. Obviously, this is a isosceles right angle triangle. So 45 degree, 45 degree, 45 degree, 45 degree, right? This is a right angle triangle. So in this case, the angle A equal to 90 degree. And then if BC is the leg, then this is the A, this is the BC. So now this is perpendicular, this is the A, this is the 2A, AB equal to BC to 2A. And then quite obvious, the leg opposed to B is the half of the hypotenuse. So this angle is a 30 degree. So angle B is a 30 degree. Angle A, because it's a isosceles triangle, is 75 degree. So the answer is 75 degree or 90 degree, right? So this is the open question 10. Now this is the easiest question in the all the 4 questions in the open group. Okay. Then we go to the last question, question 15. I remember we just talked about this one in P5CO last week. Yeah. So it's about square numbers. So AA, B, C, D are square numbers. B, C, D, A are also square numbers. And then we want to find, so how many such numbers are there? It's not D equal to 0, so it's the D that's not equal to 0. Well, never mind. So it makes no difference. So generally, we can start with this number. So BCDAA is square number. So now, the last two digits of a square number is equal. So how could this value be? So I would tell you that A must equal to 4. Why is that? So this is the conclusion. If the last digit of a square number is equal, then this number must be 4, because the last digit could be 0, 1, 4, 5, 6, 9, right? 0, 1, 4, 5, 6, 9. So now, which means, so this A could be one of the 6 numbers, but also we should know that a square number divided by 4, the remainder is either 0 or 1. So 0, 0 work is multiple 4. 1, 1, 5, 5, 9, 9, and 6, 6 don't have the proper remainder when divided by 4. So which means the last two digits must be 4, 4. So now, first we determine the value of A. A cannot be 0, so A is the 4. And then, secondly, A is also the first digit of this number. So this 4, 4, B, C, D is squared. So whose square is it? Whose square is it? So now it should be for me. So now we should do the estimation. So now this one, we delete the last two digits, is the 4, 4B something. 4, 4B is quite close to the 4, 4, 1, right? 4, 4, 1. 4, 4, 1 is 21 square. So we know that 21 square is the 4, 4, 1, which means the 210 square will then equal to 44100, right? So the first number that starts with 4, 4 and is a square number, so it's the 44100. But now the interest says this is not 0, this is not the number we need, right? It's not the number we need, right? So now it's the 211 square. So you can just time them up, or maybe the square difference, just plus a 421 here. So it's the 44521. Yeah. And then 212 square is the 44944. Obviously, this is the largest, right? So now these are the only 2 square numbers that start with the 4, 4, and it's a 5-digit number. Use the estimation of first few digits, and then I just write the answer. So 44B00, and then 21 square. So now it's the 10 square times 44B. Just the logic to estimation just goes this way. So now these are the 2 numbers actually. These are the only 2 numbers start with 4, 4. It's a square number. And then we just revise it to C. So now we make a 12544. And this is 44944. So this number itself is a square number, of course, right? It works. Yeah. And then, so 12544. And for this 125, is this square number? Actually, it is. It's a 108. Yeah, it's 108 square. It's no, it's not 108. Who square is 12544? 112 square. 112 square. So this is the only 2 number here. 12544, 44944. And do you know the interesting? So the interesting is, if you look at this 44100, it goes for the 00144, which is the 12 square. It's also a square number. Hey, interesting is this one is also a square number, right? So you can use the place value to extend the perfect square to know how this interesting is. So we have 3 consecutive square numbers, and to revise it, it's also a square number. It's also a square number. Quite interesting, right? So this is the last question of open group. Okay, I finished all the 15 questions that I got here. So which means I have 4 last questions from, I don't know the remaining 4 questions in the junior. And then how many questions in the open do I miss? So in the open, I know 1, 2, 3, 4, 5, 6. Okay, I may need one more question open, or maybe I get all the questions from the open, right? Maybe I already get all the questions from the open, but I still have 4 questions of junior unknown. So if you know, please send me. And then the network is not that good, so maybe stop here. And then I will send this note to the group, but after I get the correct version of the questions. Okay, so that's all for today. Yeah, maybe we stop here.